Okay, when this stops spinning, we'll start the slideshow. Okay, so today we're going to talk about ozone. Hopefully you took some notes in the video. That's probably going to be the best illustration you see of ozone today, because what ozone is just a molecule. It's O3, so oxygen, 3 oxygen atoms that are bound onto each other. The ozone layer hole is essentially a hole in the stratosphere that is taking ozone out of that layer because it's binding one of the oxygens onto other molecules so that you end up with only O2 instead of O3. So here's our goals and objectives for today. The main focus here is understanding stratospheric ozone depletion. And if there's kind of one thing I want you to take home today, it's that there's this difference between good ozone and bad ozone. So ozone is slightly confusing because when it's in the troposphere, it's bad, and when it's in the stratosphere, it's good. And that does tend to confuse students. So I have about 3 different slides that is just going over that again and again and the reasons around it. I want you to understand just the basics of how stratospheric ozone protects the surface of the Earth from UV radiation. And then we're going to look a little bit at the health impacts of tropospheric ozone. And finally, we're going to discuss how the Montreal Protocol, which you read about for today, helped to solve the problem of stratospheric ozone depletion. So just a reminder, this is our planetary boundaries. This is what we've been looking at all semester. And we are now here. So we just finished discussing climate change. And we put some renewable energies in our conversation, or I'm sorry, renewables and non-renewables in the conversation on climate change. And now we're here talking about stratospheric ozone depletion today. From here, we're going to talk about biosphere integrity beginning on Wednesday. And then this will be our last unit, the biosphere integrity unit. We will end with, this will be our last of the planetary boundaries. We'll end with a little short 1-week unit where I talk about sustainability and sustainability science, and just give you an idea of how that differs from environmental science, and particularly for those of you interested in pursuing the major, but also just kind of understanding what we're talking about with the differences and what people and experts are thinking about in terms of the possibilities of solving some of these problems you've been spending all semester learning about. Okay, so this is similar, I think it was kind of better in your video. Sorry. But this is the chemical reaction that we're talking about with ozone. And this chemical reaction in the stratosphere is what protects the surface of the Earth, where we are living, from receiving as much ultraviolet radiation as it could. Okay, so this is another function of the atmospheric gases that protect us and create a nice environment for us on the surface of the Earth. And it's also another function that we have been essentially messing with through our activities on Earth. Okay, so here you have 2 oxygen molecules that are bound together, and then you're seeing here this is showing you this ultraviolet radiation. And what happens is ultraviolet radiation comes in and it hits these oxygen molecules and then it breaks them apart. And when it breaks them apart, then one of these oxygen molecules can form with another diatomic oxygen to make O3, which is ozone. And actually, okay, I thought I might have the slide here. And so in this reaction, you'll also get more ultraviolet breaking apart these ozone and reforming the diatomic oxygen. So this reaction actually goes back and forth with the ultraviolet radiation. And so what it's essentially doing is it's absorbing this ultraviolet radiation in the stratosphere through this layer so that these rays don't actually pass through to the Earth's surface. They're being essentially bound up in these chemical reactions that are happening in the stratosphere. And that is why ozone, this ozone-oxygen cycle is important to us, because it's causing this harmful ultraviolet radiation, which can cause damage to our living tissues, and it's converting it into heat. Okay. So here is what you saw in the video, which is that there are that chlorine and other, they mentioned bromine as well, and they're all in the same family of elements in the periodic table. If you remember your periodic tables and you look at it, I'm already forgetting the name of them. I can't remember the name, but they're all in the same family on the periodic table. And so chlorine can actually bind up with, sorry, oh, my cursor. Okay, so the chlorine can bind up with one of the oxygen molecules. And when it does that, it prevents it from forming more of this ozone, right? And so this is what you saw in that video where the chlorine comes in and it essentially takes some of the free oxygen out of the atmosphere and binds onto it so that it can't form ozone. And that's what we mean by the destruction of ozone, right? And the other thing that they showed you that happens is that one chlorine molecule can continuously bind onto these oxygen molecules, so it can actually destroy a lot more ozone than, like it can be recycled in the destruction of ozone. Okay, so this is the video that you saw, or hopefully saw, and if for some reason you missed my email and you don't know what I'm talking about, read your email, and this video is posted on Moodle for you to take a look at. And I like the video because it just shows kind of in real time what's happening with this ozone hole. I think in my experience, ozone, in fact, the first couple years I taught this course, I didn't even teach ozone because I just thought it would confuse students. And finally, I figured out this simple way to explain it to everybody, and it seems to work. So watch the video, and it'll show how this hole actually will continuously form over the Antarctic every year. And in particular, as we've already learned with the poles, increased radiation at the poles is particularly problematic because of positive feedback loops involving decreased ice melt and albedo at the poles. Okay, so here, everything that we've been learning about up until right now is about stratospheric ozone. So the stratosphere is the layer of the atmosphere that is above the troposphere. So the troposphere is where we are. That's what we're living and breathing in. And above that is the stratosphere. So in a couple, unfortunately, it's not this slide right here, but in a couple slides, I'll show you, it'll show that kind of layering in the atmosphere. Okay, so ozone in the stratosphere, good. Ozone in the troposphere is bad. So when you hear about, like you've probably seen on weather apps, it'll say ozone is high today and you need to be careful, right? Ozone is essentially a form of air pollution on the ground level. And the way that it's formed is that this reactive nitrogen that we produce, so remember our NOx, right? So our nitrogen dioxides and other nitrogens that we produce can combine with volatile organic compounds, and then the heat and the sunlight, and they'll produce ozone at the ground level, okay? And ground level ozone, so ground level ozone is created through these chemical reactions and essentially is like a smog product, right? And ground level ozone is considered a pollutant, okay? And the reason that it's considered a pollutant is that it's bad for your lungs. So it's an oxidant that can irritate your airways, make it hard to breathe, and cause health issues that way. And this is a picture for those of you that haven't taken human biology in a while. The way that your lungs work is that the air goes in through your bronchi into your bronchioli and then ends up in these alveoli, which is where the oxygen diffuses into capillaries, and that's how oxygen gets to your body. And so it can actually cause these to constrict. leading to shortness of breath and wheezing, and obviously being potentially particularly problematic for people with other lung conditions. Okay, so here's my little diagram for you where it really breaks down. So here's your lower atmosphere ozone, right? And this is bad. So this is the troposphere, and ground level ozone is bad. It's a major component of smog, and it comes through fossil fuel emissions, including car and factory emissions. So our fossil fuels have more than just carbon dioxide coming out when they burn. They produce other contaminants as well, and those can contribute to smog, okay? Here is what I was talking about with the layer of the earth, that's the stratosphere, so the upper atmosphere, or I'm sorry, the stratosphere, and then above that you have other layers of the atmosphere before you end up in outer space. And so here is where ozone is good, right? So ozone in this layer of the stratosphere, this is where it's protecting us from the UV radiation. And so keeping some of those damaging sun rays from reaching the ground of the earth. And then they're showing you this picture where aerosol emissions are damaging our stratospheric ozone layer, right? And so you all would not probably remember this because it would have been before you were born, but in the 80s, there was a big campaign against aerosols and like hairsprays and things like that, which only slightly makes me chuckle because, as you would have read about for today, the real target of the Montreal Protocol was less people's individual hairspray cans and more large manufacturing companies that were producing CFCs that were going into the atmosphere, right? Of course, aerosols and spray cans were also bad, but the scale of that was pretty minor compared to other things. But as many things in the United States, there was like a campaign for the individual consumer as well against aerosols. Okay, this, I feel like I used to have you all read a paper on this, but don't anymore. But again, this is just showing you, if you look, this is looking at the same concept as this kind of fun diagram in a figure, right? And so here you see that as you go up in kilometers, right? So this is kilometers above the earth. This is the amount of ozone that we tend to find, right? So on the ground level, when you have a bit, this would be our smog ozone. And then as you move up in kilometers, you move into the stratosphere, and this is your stratospheric ozone layer, right? Where you have kind of a dramatic increase, or you should have a dramatic increase in ozone in this upper stratosphere, which again protects us from UV radiation. So here's just kind of a breakdown of the concerns about the stratospheric ozone layer in general. This is one of the more success stories we have in the environmental movement, and that's what we'll talk about in a minute with the Montreal Protocol. But we have done a lot. You'll hear scientists less concerned about stratospheric ozone depletion today than we were, back in the 80s, of the example that I gave you of. And that's because of the Montreal Protocol, and that we've done things to stop the production of so many CFCs in factories across the world, right? And so, however, as the video that you saw for today pointed out, there is, we have enough stuff that we released into the atmosphere already that we still have it continuing to cause ozone holes each year. So we had, I think it was back in the 80s, there was a huge one over, the big concern was one over Australia and other areas of the globe, and those have become less of a concern, but we still have these Antarctic and Arctic ozone losses over the years. Okay, and then here on the ground level, this is where we have this harmful impact. It can also impact vegetation, and then we talked about it upsetting human lungs in particular. And this is the kind of thing where we're going to see more of it in urban areas where we have more dense smog. But one thing to keep in mind whenever we're talking about air pollution is air pollution travels. And so often it's the areas, in fact, I read a cool paper once about it's the areas that in this country, it's areas that tend to be kind of east because of wind patterns of major urbanized areas. And that's where we see the negative impacts of air pollution. So air pollution will travel. In a video that I show in my SUS class, they talk about how in California, they've done all this work on air pollution restriction or on air pollution improvements, only to have pollution actually travel all the way over from Asia to negatively offset some of the progress that they've made. So this is kind of how, this is the reality of what sometimes we consider global environmental problems, right? That they can travel from one place to another. And that's one of the reasons why we sometimes need larger scale governance to be able to address some of these issues. Okay, as I said, short lecture to the point. If you are not on Zoom right now and you're watching this over my awesome YouTube channel, then what I would recommend, because you're not going to be talking about this in your groups, is that I would recommend that you would talk about this. I'm sorry, that you would probably write up a little answer for yourself about this. So answer this in kind of a guided reading question type of manner. Okay. So that's it for my recorded portion of the lecture. And everybody else, just stay where you are while I stop this. Where'd it go? I should be able to stop the recording. There it is. Okay, well, I stop recording.